So in this lecture, we will discuss about what is a point-to-point model. In the starting itself, we have told that for the mobile radio environment, the area-to-area model is not these are all the prediction models is not suitable. So we will be implementing the point-to-point model. For that, we have seen what is the area-to-area model and different types of path loss slopes in the mobile environment, in the free space, in the over the water. And we have seen the point-to-point model for the that is different cases. So in here you will see the what is the form of a point-to-point model, what are the main points, advantages and disadvantages. So Lee developed, this is also called as a point-to-point model, is also called as a Lee model. So Lee developed this point-to-point model in 1977 and its software implementation at AT&T Bell Lab called ACE, area coverage estimation. This model is a methodology, not a formula. So we have to follow some steps. The man-made environments are different in different areas, and to predict the signal strength on every local street is needed in the first build-up cellular system for coverage purposes. This model can provide quality coverage with minimum equipment. However, this model needs a terrain database and a computer program. Therefore, it is not easy to use a formula for a quick prediction to be referred in the academic papers. Nevertheless, the prediction results can provide an amazing match with the actual measured data as AirTouch constantly made evaluation internally with other market models. So here the general formula for the Lee model is, it can be simply split into three cases: direct wave case, shadow case and over the water condition. So in the direct wave case, the effective antenna height is a major factor which varies with the location of the mobile. Already I told the effective antenna height is nothing but the height of the place where the mobile is located and the height of the mobile antenna. So it varies with the location of the place of the mobile. So the effective antenna height is a major factor which varies with the location of the mobile unit while it travels. So in that case, it's what is the formula for Lee model. The second case is no effective antenna height exists. The loss is totally due to the knife edge diffraction loss. Third one is over the water condition. Over the water and free space path loss both are same. We have derived in the previous lecture. So coming to the model, the formula is received power is equal to, in the case of non-obstructive path, obstructive path and land to mobile over water. This is the formula from the case of non-obstructive path. So PRO minus gamma log of R by R naught is the human made structure for the received power and by terrain contour. So in the non-obstructive, we have to combine both human made and terrain contour. 20 log of HE dash by H1. HE dash is the effective antenna height plus alpha. So the second one, obstructive path, is PR0 minus gamma, same 20 log plus L plus, say here the diffraction loss is coming into capital L is the diffraction loss. So next, coming to the obstructive path, you are having where HE double dash is shown in figure, which we will see in that. So next is by human made structure and by terrain contour, here the diffraction loss is added. So here when HE double dash is equal to H1 means this is becoming as 1 is 0, it is eliminating here. When the both are same, the effective antenna height is equal to normal antenna height. This term is removed and this is the formula for the terrain contour. And for the land to mobile over water, it is a free space found 20 dB per decade. So, okay, this is the formula for the three cases. Next, coming to the received power. So, the way the PR cannot be higher than the from the free space path loss slope. The road's orientation, it is within 22 miles from the cell site, will affect the received power at the mobile unit. The received power at the mobile unit traveling along an inline road can be 10 dB higher than that along a particular road. Alpha is the correction factor obtained from the condition. That is, we have seen the starting, standard and correction factors. The foliage loss would be added depending on each individual situation. Avoid choosing a cell site in the forest. Be sure that the antenna height of the cell site is higher than the top of the trees. Within 1 mile, in a man-made environment, the received signal is affected by the buildings and street orientations. The macro cell prediction formula. This is the formula. The macro cell prediction formula cannot be applied in such areas. In the case of within the 1 mile, a macro cell prediction model by Lee is introduced and described. So you can see, refer that paper. So the merits of the point-to-point model are, what are the advantages when we are going for point-to-point model is, The area-to-area model usually provides an accuracy of prediction with a standard deviation of 8 dB, which means that 68% of the actual path loss data are within the plus or minus 8 dB of the predicted value. The uncertainty range is too large when it is 8 dB. The point-to-point model reduces the uncertainty range by including the detailed terrain contour information in the path loss predictions. Differences between the predicted values and the measured values for the point-to-point model were determined in many areas. In the following discussion, we compare the differences shown in the Whiffany NJ area and the Camden Philadelphia area. First, we plot the points predicted values at the x-axis and the measured values at the y-axis. You can see here, when we are plotting, you can see prediction without error is this is the one, and the deviation of the for the Whiffany area and Camden area, the deviation is only 0.8 dB. That is, you can say it is 2 dB. So the point-to-point model is very useful. You can see here x-axis is predicted in dB and y-axis is the measured in dB. So what is that we are getting is, when we are taking the point-to-point model, it is very useful for designing a mobile cellular system. The radius for each cell of 10 mylar, the coverage areas are less because the data follow the log normal distribution. 68% of the predicted values obtained from a point-to-point prediction model are within 2 to 3 dB. When we are going for point to model, the predicted values that varies are within 2 to 3 dB. It is very less value. When compared to area prediction, it is 8 dB. So this point-to-point prediction model can be used to provide overall coverage of all cell sites and to avoid co-channel interference. Moreover, the occurrence of handoff in the cellular system can be predicted more accurately with the help of point-to-point prediction model. The point-to-point prediction model is a basic tool that is used to generate a signal coverage map, an interference area map, handoff occurrence map, optimum system design configuration, to name a few applications. So it is helpful. The point-to-point prediction model is becoming a basic tool for many such applications. So this is about the point-to-point model, its merits, the merits of the point-to-point model. You can see the mean value here, the mean value, when we are getting it as a 3 dB. Standard deviation is range is much reduced as compared to the maximum of 3 dB for the area-to-area prediction model. And the advantages of the point-to-point model are it can be used for signal coverage, interference area map, and occurrence map, and optimum design configuration. So these are the advantages of point-to-point model or Lee model. Both are same. So thank you.